Um, our first speaker for this afternoon is Elina Teplinsky, hailing from right here in New York by way of Belarus. Elina received her law degree from Fordham University and is now a partner with Pillsbury, Winthrop, Schue, Pittman, where she leads the firm's international nuclear projects and hydrogen teams. During her tenure, she represented Schue Nuclear on the development of the first nuclear power plant in Turkey. She also represented Brookfield on their acquisition of Westinghouse. And she has represented a nuclear project developer in the implementation of new projects in South America and Africa. She's a strategic advisory group member of the International Bank for Nuclear Infrastructure and has a wealth of information on nuclear financing, especially in light of last year's Inflation Reduction Act. So please join me in welcoming her. Thank you.
I have to stand at the podium. Ooh. Okay. Yeah, that would be great. So I can walk around and make this a little more casual since everyone just had a nice lunch. I want to make sure everyone is awake. This is the presentation about how to get money for more nuclear, which is obviously essential to getting more nuclear online. We already heard during the first part of the day that we need a lot more nuclear for decarbonization, not just for the power sector, but for all of the parts of the economy, especially the hard-to-abate sectors. And if you look at some of the numbers coming out there, and some of them are actually pretty conservative, the International Energy Agency says we need to at least triple the investment into nuclear by 2030 to meet our decarbonization goals. And that's a pretty tall task. If you look at, just back of the envelope math, think about 1 gigawatt. How much does 1 gigawatt cost? Let's say conservatively, $5 billion, not in the West, let's say in China. If we're going to double the capacity, just double, not triple the capacity of nuclear, times that by about 400 gigawatts, that's at least $2 trillion, right? That is a lot of money. And if you look at the trajectory of nuclear over the past couple of decades, it's pretty much been stagnant. Since we've built fleets of reactors in the 60s and the 70s, we've been at this level of about 10% of energy capacity. And nuclear is the second largest firm clean energy source after hydro. So with hydro, we're basically tapped out, most of the world. In nuclear, we can grow, right? Because we're not limited to having to dam the rivers and the other bodies that exist, but we've been pretty stagnant. And of course, the impediment to the growth of nuclear is also the impediment to our ability to decarbonize. So why have we been stagnant? That could be a whole separate talk. But from kind of a really high level point of view, nuclear reactors, the large nuclear reactors we have today are very expensive. To just build a single reactor, and they're usually built in 2s and 4s, we're looking at, $10 billion, $20 billion, $30 billion, depending on the size of the reactor and where you build it. That is a lot of capital. Historically, the financing of these reactors has been done in 2 ways. One, by governments. So there's some governments that can afford and want to have a policy to finance domestic buildup of nuclear. One example is China, all being done with state funds. Another example is Russia. Even countries like France in the West, and mostly done it with government funds. You have EDF, that's a state-owned utility. The other source has been the balance sheets of big corporates, mostly electric utilities. So here in the United States, where we don't have a publicly owned nuclear sector, we've been basically asking electric utilities to put their balance sheets up for risk in order to finance new nuclear. And guess what? That hasn't worked too well. Companies that even announce that they're going to build new nuclear, the credit rating immediately goes down because the expectation is that these are very large projects, they're complex, and in the West, because we've had gaps in building new nuclear, it's almost like a self-fulfilling prophecy, right? We haven't built new nuclear in a long time, so we don't really know how to build it. We don't have the regulatory capacity necessarily to support significant buildup. So immediately we're going to get a credit down rating even before we start doing it. And that prevents people from coming to in the market to actually finance new nuclear and build up that capacity so we can bring the cost down. So it's been quite difficult. This is one of the reasons that small modular reactors has been seen as a way to ramp up that capacity, right? I think most of you in the room know about SMRs. SMRs are smaller, so that means a lower capital cost. They are modular, so that means less construction. It means you can fabricate the modules in the factory, you can bring them to the site. Most of the work is more on the installation side rather than construction, so you don't have 500 work packages that all have to be integrated. You just have a module that you can mostly install, and the construction work is not as significant. And then because you have smaller projects, the development timelines are also shorter. And that means that the capital outlay and the cost of interest rates, right? Imagine when you get money for anything, let's say you take out a mortgage, right? The longer your mortgage, the more the property costs at the end of the day. And that's exactly what things look like for nuclear. If you had nuclear built in the same timelines as solar and wind, or even conventional power, natural gas, CCGT, 2-3 years, the interest rate, the weighted average interest rate costs are one thing. If it takes you 10 years to build it, the cost goes up about tenfold. So SMRs can really be a solution, and there's been some skepticism generally. Okay, SMRs look great on paper, it's a wonderful concept, but we don't really have any operating ones. Is this just a PowerPoint presentation? Is it just an idea? Is it real? And I think we're finally in the last year or two starting to see that this is becoming a reality. For all of the reasons that we started discussing today, the need for decarbonization, but also the need to have something that can be deployed on a faster scale with less capital, you're actually starting to see real projects being developed with actual sites. That to me is when it starts becoming real, when there's an actual site. And that site is starting to be developed for a particular reactor, or at least the perimeter for several reactors. And you actually have, as a lawyer, one thing I really, really hate, I can tell you, are MOUs, Memoranda of Understanding. And here in North America, I've been doing MOUs for 15 years. I'm finally now negotiating real contracts to purchase real equipment, like the real hardware. So that to me is a signal that this is real. Somebody's spending money, putting that down payment to buy a widget, not just to produce more services, an engineering report and put together a proud presentation for a nice conference. So that's, all very exciting. But I still retain some dose of reality, right? That we're now at a point where we're ordering equipment, we've got a couple of sites, but there's still so much to do, right? If we're going to need to double or triple the capacity of nuclear, 400 gigawatts more, 800 gigawatts more of nuclear online, that is a lot. That's a lot of projects, a lot of investment, and a lot of potential to fail. Very frankly. So these projects, they look like they're doing the right thing, right? They're taking into account lessons learned from the large projects. They're approaching new licensing pathways. They're getting other parts of the industry involved. They're trying to reduce costs. But we actually have to have scale in order for these to become a reality. So this presentation, there are a lot of things that I've been advocating for that need to be done to make this new nuclear market a reality, and also to bring in private funds into it. And there's a role for everyone involved. So one, there's a role for government, right? The governments really need to recognize the zero carbon value of nuclear and invest into nuclear the same way that they have invested in renewables and other infrastructure to scale it up. So we're already seeing a lot of that across the world. Right here in the United States, we're seeing the Department of Energy with its Advanced Reactor Demonstration Program. We now have the Inflation Reduction Act with tax credits that are for clean electricity and specifically include nuclear. So nuclear is now on the same level paying as renewables, where it previously wasn't. We've got loan guarantees available for nuclear. And we're seeing that in other countries like Canada that is also supporting nuclear, actually investing into some of the new technologies and providing different types of incentives to do it. So for us to really get the market started, these demos need to be funded, right? Because nobody wants to be the first one. No private entity is going to want to invest their money into essentially what is a PowerPoint presentation. And to be very frank, that's where a lot of things start out, right? Somebody comes up with a concept, it's an engineering idea, it looks great, it's got this, coolant that will ensure that the fuel can never melt, to some of the questions about safety, it's got these cost reduction mechanisms, but it actually needs to be a reality and it needs to actually be proven and operational. So we really need the governments to invest into these first of a kinds because private industry is not going to do so. And then the debt as well, right? We need the equity, we need the actual capital costs, but everything can be financed with, 100% dollar per dollar. We need the governments to provide some debt for the demos as well. And that's being done, across the board already in some ways. We have the loan guarantee program in the US. In Canada, we have the Canadian Infrastructure Bank that has provided $708 million to the new reactors, the BWRX 300s in Ontario. But there are many other pieces still missing. One is licensing and supply chain. So the licensing regimes today are designed for large light water reactors, generally across the board. In Canada, they were more designed for pressurized heavy water reactors. We don't really have licensing regimes that have been designed for small modular reactors, for some of those, safety features, like the fact that you have fuel that can't melt, the fact that you don't need as many operators, the fact that you can site them much closer to population centers, which is also important for use in industrial end uses, because a lot of industry is not located in the boondocks, right? They're located close to population centers. So the regimes really need to be adjusted for this, and there are efforts to do that, but there's still a lot of work to be done, especially here in the US. We have a very prescriptive regime. And then issues like some of you may be aware of the high assay low enriched uranium issue. So you have to have a uranium that's enriched to slightly higher levels for advanced reactors. We don't have that available in the market today, especially not in the West. There's some capacity in China and in Russia. Makes it hard given the geopolitics today. So there needs to be a lot of investment by governments too into those types of supply chain issues to ramp them up until private industry can jump in. But, kind of in the nuclear industry, we tend to put a lot of onus and blame on government. Yes, it's the government's fault. The government's not providing the right policies. The government's not providing enough money. And that is very true. We definitely need more support from government, but industry itself also has to organize or really reorganize in order to create this new market. So right now, the way that things are done in the industry is that projects are approached in very much on a case-by-case basis, right? So you've got one utility or one potential end user, they have a project that they're doing, and we advise on a lot of these projects, and I swear to God, every time a company approaches me with a new project, it's like they've never built nuclear before anywhere in the world. Like, we're looking at this for the very first time. We've got this new technology we're building. We're going to invent the contract from scratch. We're going to just do it in a vacuum. And it's like, no, guys, there's 400 gigawatts of nuclear operating. We've done this before. And maybe we haven't done it in the US consistently lately, but it's been done everywhere else, and it's been done in many other places successfully. And by the way, your neighbor down the street, your utility, and the one state over, they're doing the same exercise. And you guys are not talking to each other, and you're talking to the same vendors. So what we really need is a lot more collaboration industry-wide. We're starting to see some of that. One really good example is you've got OPG in Canada that is working with TVA in the United States and with Synthos in Poland, which is actually not a utility, they're an industrial player, and they're jointly co-funding the detailed design for the GE small modular reactor. And they're going to share costs to bring that reactor online to basically speed up the development timeline and bring that reactor online in the same time, hopefully the same time in Canada, US, and Poland. And that means that one, they share all the costs, right, in the early development, then they share lessons learned, and they also cooperate on the development of a fleet of reactors, which means better supply chain, lower costs, kind of better across the board. So we're seeing, this happening on a case-by-case basis, but we really do need to have a lot more collaboration across the potential end users to make this a reality. There's also a role for industry to reach outside of our kind of, typical end users, our nuclear circle. So historically, the end users for nuclear energy are the electric utilities, right? They're the customers. Electric utilities are not great investors because, they're utility companies, right? They're not competing with anybody. They're very conservative. They have to answer to utility commissions. They're not risk takers by their very nature. So here we're talking about these novel technologies, novel deployment methods, and then we're taking the guys who are probably the most risk averse, and we're asking them to take that risk. Not the best method. You've got a ton of other potential players out there that are under pressure to decarbonize for various reasons, right? And some of them, it's their own survival. They've got to answer to ESG guidelines and pressures from investors, where some of these companies cannot get debt from the investment communities unless they decarbonize. And I'm talking about, the oil and gas guys. You've got similarly, voluntary commitments, but also similar pressure on a lot of the big companies, which are, the tech industry, right? It's the Microsofts and the Amazons of the world and the Googles of the world that suck up a lot of energy, right, to be able to operate things like data centers, to be able to do all the logistics. All of us get all the stuff from Amazon, right? It requires a lot of energy to be delivered to you. You use cloud services for all of your documents, huge amounts of energy. So these companies need the energy. And I think until recently, they really haven't been a target for the industry to say, hey, we could really help you decarbonize with our technologies, but you've got the big balance sheets and you have research and development budgets. Why don't you help us out by investing? I think that's finally coming together. We're seeing, for example, Dow, with, of course, one of the world's biggest chemical companies, sign an agreement with X-Energy, where they're actually going to be the very first buyer of that reactor. But we need to see a lot more of that across the board. We really need to close the loop with industry. And then, of course, this is kind of a given, but the industry has to learn from past mistakes. As I mentioned, a lot of times these projects are being pursued like they haven't been ever pursued before. We need to think of all of the things that have gone wrong in the large projects, and we need to address them in the small modular reactor deployment. But we also have to think about some of the things that could really go wrong with the SMRs. So I was talking before about, all the risks in construction and trying to decrease those risks with modularization and manufacturing. But guess what? There are risks on the manufacturing side too. We've seen some of these issues in some of the nuclear deployments where the facilities that were manufacturing some of the equipment didn't have the right nuclear standards or couldn't comply with them, or didn't have staff that was familiar with nuclear, couldn't abide by the quality assurance requirements. So these are all the things we have to think about. What are the risk points? We really have to address those, because without that, we're going to have failed projects, demos, and unfortunately, it's going to undercut our ability to really scale the nuclear industry. So even with all of that said, we still have gaps. Even if we do all the right things, we've got the government support, we've got new end users, and we've got the industry doing what it's supposed to do, we still have gaps. And why do we have those gaps? if you look at how infrastructure is financed worldwide, in developing economies, almost 100% of it is financed with support from multilateral institutions. That's the World Bank, that's the African Development Bank, the Asian Development Bank, all the regional development banks. And these banks, even in developed economies, for example, the European Infrastructure Bank has been responsible for financing a lot of the European infrastructure right in Europe. These banks do not finance nuclear. The World Bank has specifically a policy that says we do not finance nuclear, in the same vein that we don't finance terrorism and child trafficking. It's a really, really great list to be part of. And there are other banks, if you look at the European Infrastructure Bank, they're actually supposed to finance nuclear, but they don't. And why don't they? Because they've never financed it before. And they don't know anything about nuclear technology. Their perception is that it's risky. Maybe there are safety issues they don't know about because they haven't asked the question. They're worried about their cost overruns, schedule delays, all of those typical things that we talk about. And I've worked for several years on campaigns to try to change the policy of the World Bank. Because if you look at who actually are the top members of the World Bank, the countries that have nuclear. It's the United States, it's France, it's China, but it's not changing because everything operates on consensus. So a country like Luxembourg, is very anti-nuclear. If they're part of a working group, they can single-handedly influence a policy because they essentially have a veto right. If you just have a single anti-nuclear member. So for that reason, I've become involved with a concept that's grown and an initiative that's really grown over the past 2 years to establish the International Bank for Nuclear Infrastructure. Sometimes we call it the World Bank for Nuclear. So what we're trying to do is use all of these existing mechanisms that already exist, right? For every dollar that the World Bank finances, they get $100 from private industry or from other governments, from sovereign wealth funds. So this is a proven way to finance infrastructure, whether power or anything that involves building some sort of an asset. So we can use that across the board, but because nuclear, for good and for bad, it's special, right? It's special for all the positive things it can do, but it's also, unfortunately, special in that, it has these regulatory challenges. It's very complex, difficult for average people to understand, and doesn't have any experience with global financial institutions because they've never financed it. So the idea is to have a bank, the members of which are countries that support nuclear. So it's either countries that already have nuclear or that want to have nuclear in the future. The governance is done exactly the same way as the World Bank or any other institution. The structure is already there to be able to dip into money from private markets, but it will have the nuclear expertise. It will have a realistic view of the risks and rewards of nuclear. So it won't scrutinize it from an anti-nuclear viewpoint. And it'll also be able to address some of the issues that I talked about, set the right standards so that we can actually have successful nuclear projects, right? The way it will work is that somebody wants money from the bank will be able to come and say, we're only going to finance successful projects. So your project needs to be de-risked in all of the following ways so that it's actually a success and we can bring in money from private markets. So this initiative is underway. We're trying to get 7 governments as kind of the co-founders of the bank: US, Canada, France, UK, Japan, Korea, and the UAE. We've been engaging with all of these governments. We've gotten some really positive traction. We're trying to get a declaration at COP28. At least several of these governments, they are supportive of the creation of this bank. So we really are on a good trajectory there, largely because we have these needs for decarbonization and energy security that nuclear can provide. But we're looking for more support. So any organizations that want to support this concept, very welcome to join in on the campaign. And if you have any questions, this is typically like a 2-hour presentation on the bank. So happy to share with you any information. And thanks very much for the opportunity.
Hello, is this thing on? I think we have time for maybe 1 or 2 questions, if anybody has any. Yeah, come around with the mic.
Sorry. Hi, just to say number one, we're really fortunate to have you here. In the model you're talking about, just to talk about maybe the OPG, Synthos, TVA, how do you reconcile the supply chain for that model? Because we're going to build one in Canada, and now with all the funding with the IRA and all the tax credits here and there, and whether I can't imagine that the world, the US and the Polish are going to let Canada be the supply chain for the world, because they're going to build lots of these things. How do you reconcile that part of this picture?
It's a really good question, because absolutely every government that says we're going to fund nuclear, they also say we want to have everything manufactured right here, whether it's US or Canada or or Poland. I think it's going to have to be a blend. So you can have in a global supply chain for some parts, and there will be some parts that will be localized. The easy thing to localize is anything that's local, right? All the surrounding infrastructure, the construction is going to have to be local. Some of the supplying could be local, but truthfully, you will need to have global supply. And I think there's a little bit of a misperception, for example, under the IRA, that everything has to be US. Most things don't have to be US. It's only steel and iron, and manufactured content with steel and iron, that's 55%. So there's significant room for global supply chain, but certainly it's a balance that you're going to have to play, because it's a political issue, right? You're going to have to grow the local industry. But if you have a 100% local supply chain, it's just never going to work.
One more question.
Hi. This is fabulous. Does do you and the bank have a way of solving the dilemma that I've seen in nuclear against other sources, where nuclear plants can last 80 years, but the financing for building them has to be paid back in 10 or 15, but there's got to be a way to solve that, and I wondered if you guys have a solution.
So, honestly, it hasn't been that the payback is not the problem, because once the plant is operational, you can pay back the money. The issue is getting the money in the first place. Because the way that banks typically look at it, commercial banks, right, they don't have a strategic objective. Their objective is to get the return on their dollar as soon as possible. So typically for project finance timelines, you're looking at 2.5, 3 years max. Until the banks want to start see revenue generated and payback, and that hasn't been possible for nuclear. And frankly, even for most SMRs, that's still a very, very ambitious endeavor. So the idea here is that the bank, the IBNI, has a strategic standpoint, right, where they can come in and they can say, okay, we can be patient capital. We can bring in the capital that's needed initially for you to start construction. And then once construction's on the way and it looks closer, then there are lots of other sources of funds that you can tap into.
I'll ask one last quick question. If you could kind of give your personal review of the Inflation Reduction Act and the inclusion of nuclear in the EU green taxonomy, do you think this is a small step for the industry or a big step, or how would you recommend it to be changed in the future by politicians?
So the IRA, I think, is great because, it does put nuclear on the same level field as renewables. It's the same, the production tax credits for wind and solar are what have allowed the costs to really come down for those facilities, and also bringing in private capital to do, project finance for those facilities. So it's very positive for nuclear to actually have those credits. It's still an issue, the same issue that I talked about with, the long deployment timelines. Even with production tax credits, you're not going to have project finance because commercial institutions are going to come in and support a project that's not going to generate revenue for 6 to 7 years. So that's still an issue. I think once we have the demos underway in the United States, and by demos I don't just mean one, but I mean 4 to 8 of each one, then I think the timelines come down, the costs come down, and then you can start getting in private capital using the production tax credits. I also think some of the other tax credits, for example, for hydrogen, where you can also use the tax credit for the hydrogen production, and you can use the electricity tax credit for the underlying nuclear facility, is helpful. The EU, that could be a whole separate conversation. I think inclusion in taxonomy is better than not being included, but at the same time, nuclear has been dubbed as transitional, which is actually, it even contravenes the definition of what nuclear is being classified under the taxonomy, right? The EU has stated we're going to need nuclear to keep operating, at least, not ramp up, but to keep operating, but they're calling it transitional because sustainable was defined as renewable. So that's still a little bit of a perception issue, but frankly, the taxonomy is just a reporting obligation. It does not actually bring, hard dollars into the projects. So I think in the EU, there's still a lot more need to figure out where is that money going to come from to finance new nuclear in the EU.
Well, thank you so much. That was such a wealth of information. So please, let's have a round of applause and go to our next speaker. All right, next up, joining us today from Washington, D.C., we have Christina Leggett. She received her PhD in nuclear engineering from UC Berkeley. She is a nuclear consultant at Booz Allen Hamilton, providing technical expertise on nuclear fuel reprocessing, waste management, and nuclear transmutation to support the DOE's Advanced Research Projects Agency. Her previous positions include working as a program manager at Department of Energy and as a nuclear engineer for the NRC. In addition, she is a board member of the American Nuclear Society and the Fuel Cycle and Waste Management Division chair, and she has written academic papers on several subjects, including the extraction of uranium from seawater, as well as today's topic, nuclear waste. So please join me in welcoming Christina Leggett.
Yeah, thank you for the very flattering introduction. So I am really excited to be here today. I was hoping there would be a clicker, but there isn't. I wanted to walk and talk, but in any event, like I said, I'm really excited to be here. Thank you to Isuru and to Carl Perez for inviting me to this wonderful event. It's been really great so far. And I'm here to talk to you about the waste, okay? And so first I'll start by saying that, you've probably heard, you've heard today, you've heard in the news and the media all about the exciting benefits and applications of nuclear. We know it's a firm, clean, emission-free baseload source of energy. We know that there are a lot of applications, especially of advanced reactors, for things like, decarbonization of other sectors. I mean, Elina mentioned the contract with Dow and BWX, X-Energy, I'm sorry about that. X-Energy for decarbonizing their things. There's desalination, there's district heating, there's space exploration. There's so many different applications of nuclear. And so some of you are probably thinking, okay, so this all sounds really nice, but what about the waste, right? And that's a question that I get a lot of times when I'm talking about how great nuclear is. And so I'm really excited to talk to you about that. Now, unfortunately, my title kind of answers that question, but we'll get into that in a minute. So, so before we get into that, I work for a 30,000 employee company, so I have to do the disclaimer and let you know that I am just one person, and I do not represent the collective opinion of my employer or any of their positions thereof. And so now that we've gotten that out of the way, let me get started. So, much to my dismay, I think America has learned about nuclear waste from Homer Simpson. And so, according to Homer, nuclear waste is this green oozing liquid that is apparently edible and it's just sprinkled all over the place in a reactor facility. And so, of course, I'm here to tell you, especially as a former NRC employee, that is not what nuclear waste is. It turns out that nuclear waste is actually dry and it's stored solid. And so to give you some perspective on the waste and where it comes from, I figured it'd be worthwhile to tell you about the life and times of a nuclear fuel assembly. And so, so the nuclear fuel that becomes waste starts out as little rods. I think you've seen some little examples out front. They're really tiny, about the size of a sugar cube, and they're filled in rods that fill this assembly. And so this assembly goes into a nuclear reactor where it resides there for a few years, creating lots of clean baseload power, at which point it is discharged into a spent fuel pool. And so at this point, this is where people tend to start referring to it as either nuclear waste or as used nuclear fuel or even as spent nuclear fuel. And so once it has been in the spent fuel pool for a suitable amount of time, it is then taken out and dried and put into dry cask storage. I guarantee you it is incredibly dry. I used to work on reviewing packages for storage and transportation of waste when I was at the NRC, and there's no way it would be stored wet. So drying is an important part of that. And so the waste is actually stored in canisters that are either vertical or even horizontal. And so if you don't get anything else out of this presentation, one of the two things I want to convey to you all is that there isn't that much of it, right? So if you were to take all of the spent fuel that's stored in the country, in the US, in spent fuel pools, and in dry cask storage, so vertical or horizontal, you come up with 90,000 metric tons of waste that is stored or that has been produced over 60 years. And that translates to about 30 terawatts of electricity. And each year we generate about 2,000 metric tons. And so to give you some perspective, the size of that would fit in a football field about 10 yards high. So the reason that's the case is that, well, it's really energy dense, right? So to give you an example, if you look at 1 gigawatt E of electricity that's produced, that's kind of a standard reactor size, you would have to use 2.5 million tons of coal. And so we all know that coal, once you have, the US itself releases about 100 million tons of waste from coal plants, right? So that's a lot of waste. It takes 3.2 or 3.1525 million solar panels to generate the same amount of energy. And at some point, I mean, let's be real, that's gonna be waste. And then 430 utility scale wind turbines, so that's probably about 2.3 megawatts each. And then compare that to nuclear, it's 27 metric tons of fuel that is used to power a reactor to produce that much energy. And so this waste is stored actually around the country. So it's a small amount, but it's actually stored in different sites around the country quite safely in licensed storage installations. And so this is a map that shows where they are stored around the country. These are generally at reactor sites or in spent fuel pools. One thing I'm really proud about with nuclear is that, and I don't think any other electricity source can say this, we keep track of our waste, right? So we know how much it is and where the sites are that it's located, as you see on this map here. And then also, not only are we storing it safely, but we're also transporting it safely around the country. So we've had 2,500 shipments of spent fuel or waste around the country with no accidents. And this has been going on for over 30 years. And so, of course, it would be nice to consolidate all of the waste into a single location, right? It's probably cheaper to do, it's easier to manage. And so, historically, there have been different centralized storage solutions that have been explored. And so I say historical only because this started a long time ago, but some people in here may know about the Yucca Mountain Project. That was going to be an initiative to store about 70,000 metric tons of waste deep underground in a geologic repository. It got highly political and was ultimately canceled. I'm not saying it's off the table, it's just that people don't want to talk about it because it's very, very controversial. So, in the meantime, what's going on right now is that you've got industries like Holtec and WCS that are looking at doing privately owned consolidated interim storage facilities. So they have 2 in New Mexico and Texas. As I understand it, I think they're kind of tied up in legal battles right now. But then there's also DOE's newly initiated consent-based siting process to develop a way of licensing an interim storage facility based on consent, after obtaining consent. And so one thing I'll say about that is that I'm actually involved with a really interesting project that's funded through DOE, in which they are trying to look at kind of co-designing a nuclear project such that the community, that a community would want, right? So instead of, let's say a utility or a reactor company saying, hey, here's a reactor here, we're gonna put it here, do you want it? The public, the community gets involved early on. And so I think that's a really interesting way of trying to co-design something that a community will want once it's ready to be licensed. And so I forgot one other thing. I didn't have enough space in this slide, but there's also interest in deep borehole disposal as well. All right, and so, all right, so I like the idea that I like the idea of consolidating the 90,000 metric tons of material in a location. But what I don't like is the idea that this should be disposed of as nuclear waste. In my mind, treating that 90,000 metric tons as nuclear waste is actually a waste of nuclear. And so here's why. So earlier in this talk, I mentioned that these pellets, they're a really dense source of energy. Now, I don't think I gave you the amount of energy that's released, but it's about, it's equivalent to a ton of coal. It's 17,000 cubic meters of natural gas. It takes about 10 of these to fuel a family's house for a year, right? Well, what if I told you that we don't even use all of it? We only use 5% of the energy content of this pellet, right? I mean, to me, it's as absurd as taking a few swigs of a Coke and throwing the rest of it away. You're not even gonna use it to clean your battery of corrosion. You're just gonna throw it away and then convince yourself that somehow it's cheaper to keep buying 6 packs of Cokes and repeating the process. That's kind of what we're doing right now. We're like, well, it's cheaper to just buy the uranium, run it in a reactor and just throw it away and buy some more. Somehow that's just cheaper, right? And so in my mind, I think that this waste, and this is why I keep putting quotation marks, it's because I don't think it's a waste. I think it's a resource. And I wanna say that if we looked at the legacy waste from the Manhattan Project as a waste, if we continue to do that, so this is 70, 80 years ago, we probably would never have discovered actinium-225. Actinium-225 is a game changer for treating cancers like prostate cancer. And it was discovered in waste that had been sitting in storage for, 80 years from the 40s, right? And so now companies are ramping up to try to make this because it has amazing impacts on treatment of different types of cancer. And so if that's exciting to me because when I was a postdoc, I also did some work on nuclear medicine, and they're using this, I believe they're radiolabeling antibodies to do this, and that's some of the work that I worked on. So my solution is don't throw it away. Let's recycle it instead. And so part of that reason, I kind of insinuated the reason here, is that it's a source of valuable elements, right? So you've got platinum group metals. We know how much there is a demand for platinum group metals, rhodium, rhenium, palladium, things like that. That's actually present in nuclear waste in significant quantities. Strontium-90, so there is a company that is looking at enabling travel to space using strontium-90, and as well as remote power applications. And so one thing I want to say about the space application that I think is also exciting is that if you want to get past Jupiter, you're obviously not going to use solar. You're not going to use chemical propulsion, but nuclear will get you there. And so this is a great source of getting that strontium-90. There's also xenon. There's a xenon space propulsion method. Zirconium, and then there are even other things like krypton-85, which right now, to my knowledge, is only obtained from Russia. And so this is actually produced in a reactor just from its operation. Now, one thing that really got me interested in, when I was in grad school, I did a project on combining fast reactors. So these are different from the reactors we have right now. They use a different energy of neutron to produce electricity. The idea was that if you combine these fast reactors with recycling, you can actually better use the materials. So like I said, you can unlock the potential, that 95, 96% potential in this fuel pellet using fast reactors. And so you can get up to 100 times higher uranium use with advanced fast reactors. Now, I'll tell you right now that there is a company called Orano that does recycling in France. And they have actually reported, even with light water reactor recycling, which is not the optimum way of recycling, that they're getting a 25-fold reduction in the amount of uranium that they use. And oh, by the way, remember those storage casks that I showed you earlier in the talk? Do you know how many they have in the entire country of France? 0. because they recycle. So it doesn't make sense to me to just keep leaving the stuff out and not disposing of it, or disposing of it. Also, Also, the recycled fuel could be used to fuel even CANDU reactors. It has been demonstrated that using that slightly enriched uranium from reprocessed fuel actually works in CANDU. And I think, Elina, you mentioned high-assay low-enriched uranium. There are actually advanced reactor companies out there that are looking at using the recycled fuel as an alternative. And of course, also, it's a large strategic domestic supply of uranium. I mean, there's a lot of growth of uranium around the world, reactors around the world. Uranium demands are gonna go up. You need more uranium. So we need to have our own supply domestically to kind of meet those demands. And so I know I have 5 minutes, so I will just wrap up by just saying that, you know, when it comes time to actually store the waste in a repository or wherever, one of the good things about recycling is that it reduces the amount of waste, the actual waste that needs to be disposed of. And you can even store it better. You can design the facility better to accommodate more waste. So you don't have to have multiple 70,000 metric ton facilities running around. And then last but not least, this is very important to me because I care a lot about the environment and protecting it. It is responsible, okay? Like, why continue to mine uranium when you don't have to? Basically, every energy source right now involves some sort of mining. So for solar panels, for wind, for batteries, you gotta do some critical mineral mining, something like that. We don't necessarily have to have that. We already have enough uranium as it is. And also, it reduces the burden of waste management on future generations. In my mind, I think it's kind of silly that people can casually say, yes, it makes sense to dispose of this waste for millions of years to come. Like, just kick that off to our kids and descendants. That just makes no sense to me. Why do that? And so the key takeaways from this are that nuclear waste is not a liquid. Rather, it's a solid that's stored in a dry container. Treating it as a nuclear waste is a waste of nuclear, and also recycling reduces the volume of waste requiring disposal while also enabling access to valuable materials. So with that, that's that. I was right at 15 minutes. Forgot about that.
Thank you, Christina. We get this question about what about the waste so much, and what a slam dunk, drop the mic presentation. I would like to just take that with me wherever I go. We have time for a few questions.
There were a couple of points that you didn't make that I think are useful, because this question, what about the waste, comes up so much. One thing is that we have a lot of toxic waste that is not radioactive, so it has a half-life up forever. Mm-hmm. And all the nuclear waste that we have, even if we couldn't recycle it, is a very small fraction of all the toxic waste in the world. And there's nothing uniquely horrible about nuclear waste. And then the other thing is, it's just fundamental physics that the more radioactive something is, the shorter its half-life.
That's right.
And so radioactive waste is, they talk about 50,000 years or something ridiculous, but it's a lot less radioactive within a century. And so the timescales are not that great. So I just wanted to make those 2 points.
Yeah, and I agree. I totally agree. One of the things I wanted to mention in this, but I couldn't fit in my exactly 15-minute talk, Matt, was the fact that, yes, you're right. I think if you do the recycling, I had a plot I was going to show on this, but if you actually recycle things, even some of those shorter-lived half-life things go away. Right, so the cesium and strontium, that's responsible for that short-lived, up to 300-year, dose and heat load and things like that. And then you're already recycling the actinide, so that gets rid of the longer-term stuff. So what are you left with, right? And so it turns out that there is some work going on, or actually, I will just say another thing you can do is transmutation if you really want to try to get down the activities to something stable, right? So it's even longer lived. But yeah, in short, I definitely agree with that. So thank you for adding that.
We have time for another question.
Hi, thanks for this presentation. You're a wonderful presenter. I think that was really easy to understand as someone with no science background. But I'm with the National Caucus of Environmental Legislators. Sorry, It's echoing for me. And I'm just wondering if there are either federal or state legislative barriers to using the nuclear waste in this way, and ways that we can, support legislation that would help, recycle nuclear waste in the way that you're saying.
Oh my God, that is one of the most important things I left out from this talk. So because a lot of people will say, like people who know a little bit about recycling, they like to say, oh, well, Carter canceled, he banned recycling in the 70s, right? But Reagan overturned that. And so what I tell people is that there is no policy against recycling, and that is evidenced by the fact that there are so many companies, including advanced reactor companies and new recycling companies like Curio, that are actually going forward and trying to do recycling. I think, and this is me speaking in my opinion, I think that, I will say that there are states right now, like Arkansas most recently and Virginia, that are looking at recycling as part of their nuclear energy plan. And so what Arkansas has done, and maybe this is something you can look into, is they recently passed legislation to look at the potential of recycling in their state, right? And so it's things like that. One thing I also tell people is that some people will say, oh, we need to keep doing research on recycling, and we've done research. I used to manage the R&D program at DOE on recycling, two of the major types. And people will say, oh, we just need to keep funding that. And it's like, we've been doing that for decades, and we know how to do it. We know how to do it really well. And so at this point, what I think we need to do, we can still do R&D, but I think we need to start looking at a demonstration. This is another thing I always tell people, like, stop saying do R&D, R&D, R&D. We know how to do separations in so many different ways. I can talk to you guys about that offline, but there are new challenges that are associated with constructing, with scaling up a facility that you're not going to see in a lab with, SEP funnels and things like that, right? Like this completely different equipment and challenges. So I think that's what I always say from my personal perspective, is that we need to move into demonstration. In fact, I say we should have an advanced recycling demonstration program, analogous to the advanced reactor demonstration program. So, yeah.
I think I'm going to selfishly ask the last question myself. We were talking about this before your talk, that sometimes as nuclear advocates, we encounter people who they will not budge at all. They say, I want renewables only renewable energy, and that is it. And I think that you have one of the best rebuttals in one of your academic papers about extracting uranium from seawater. Could you maybe talk about that briefly?
Oh, briefly, oh my God. That's gonna be hard. I actually thought that was a beautiful program. So the idea was that, I don't know how many, I usually like to ask people questions, and I know I'm out of time, but I'll give you the answer. There are 4.5 billion tons of uranium in the world's oceans, right? So that's 1,000 times more than we know is available terrestrially. And so the idea of this program that we had at DOE was to try to come up with ways of passively recovering uranium from seawater, right? Without applying, adding any chemicals to the water, or, applying any electricity or anything like that. So we developed this really cool way of doing that. And the objective was to try to get an upper bound on how much uranium could cost, right? And also drive down the cost, because at the time, extraction of uranium from seawater was like $1,000, but it ended up being $300. And so one of the things I like to say about that is, because of the sort of dynamics of, the Earth, if you were to try to recover uranium from seawater, it kind of makes nuclear kind of renewable, right? Because as you're recovering, I know it sounds crazy, and we can debate this afterwards, but as you're depleting the Earth or the ocean of uranium, there are equilibrium processes, there's uranium everywhere in the lakes and rivers and things like that, will just kind of reestablish that equilibrium. And I'm sorry, 4.5 billion tons, we're not gonna go through that in human lifetime, really. So that's that. And feel free to come talk to me about that and any of the other stuff that I've done. So.
Well, thank you so much, Dr. Leggett. Okay. So our last speaker for the afternoon, before we take a little break, is Keith Schue. Hailing from nuclear-powered upstate New York, Keith has a master's degree in electrical engineering and worked in the private sector for 14 years. He spent 5 years with the Florida chapter of the Nature Conservancy on the impacts of human development and infrastructure on ecosystems, habitat fragmentation, and large landscape conservation. In New York, he helped to ban fracking and applies his knowledge of engineering and environmental protection to review and comment on state energy policy. And in addition, he is a dedicated animal advocate and currently has 6 cats. So he is given the impression that he's trying to make the world a better place. So with that, Keith.
How would you like the mic? Would you like it in here? Advance the slides. You just arrow forward, arrow back.
Okay, thank you so much. Yeah, hi everybody. It's great to be here. Yeah, and I'm also with Nuclear New York and with another organization that I work through, which is New York Energy and Climate Advocates. So this is where I live, Otsego, beautiful Otsego County, beautiful upstate New York. This is a picture taken not far from where my home, actually. I'm an engineer. I'm an electrical engineer. I'm also a self-proclaimed environmental activist. I want to talk to you a little bit about I want to talk to you about the ecology. I want to talk to you about the environment and what nuclear can do for that. But I also want to put it in the perspective of where I am, where I came to be as somebody who is pretty much I'm an engineer, so I'm a closet supporter of nuclear power, but how I came to be a advocate, vocal advocate, proponent of nuclear power. So I got a degree in Virginia, BS and MS in electrical engineering, and I moved to Florida. This is what I thought of Florida was. This is actually what Florida is. So what you see is a tremendous amount of development. Human development across the landscape. And so I like going hiking, I like being outdoors. I spent a lot of time with the Sierra Club. I got more and more involved with the Sierra Club, and you can see some of the things that the Sierra Club stands for. These are good things. I still support these things. But one of the big issues that the Sierra Club has had is the issue of urban sprawl, or probably more correctly said suburban sprawl, which is just the proliferation of human infrastructure across the land. And so I got really involved. I actually became the local group chair for Lake County, Seminole, Osceola County for the Sierra Club. And this is what I was doing. I was fighting developments, not with a whole lot of success, but that's what we were doing. I will say that eventually I got really so interested in this stuff and really committed to it that I thought that was more interesting than my paying job. So I left my paying job as an engineer, continued some activism, but then I took a job with the Nature Conservancy. And I would say the Nature Conservancy is really where my understanding of that relationship between the human environment and the natural world and how those things truly interact, I think that's where my understanding really kind of matured. And I just want to give you an example. This is the area where I live. This is the area of Central Florida. The Wekiva-Ocala Ecological Corridor, tremendous ecological value of ecosystems that are from the Central Florida area stretching up to the Ocala National Forest. What you're seeing in red here is all the development that was happening, still happening. And that corridor that ecological corridor was being bisected by lots of road projects and intrusion of residential development. And there were, we had a beltway around Orlando, or almost a beltway, and there was a push to extend that beltway and complete it, crossing through this ecological corridor. And so a lot of us in the environmental community were saying, we got to stop that. Roads are bad, expanding roads are bad, it's terrible. We certainly can't have a beltway. But then we got to realize, you could do that, but it's still going to clobber wildlife. You're going to basically fragment the corridor that way. And we changed our mind. Me and some others within the environmental community said, okay, you want to build a beltway? Let's build a beltway. But let's make it something totally different than anything you've seen before. Let's make it something with wildlife passages underneath the road. And we buy some land for preservation around it too. So I think there's a lesson to be learned there that sometimes the thing you fear the most, the thing that you think is the enemy, is the thing that can actually save you. And I think there's a kind of an analogy there with nuclear power. When I moved to New York, This was a different kind of sprawl that we were fighting. You know, the proliferation of fracking, the proliferation of these gas wells potentially across the landscape of upstate New York. And, you know, these are some of the messaging we use. You know, this is the countryside we have today. Is this what we want it to look like in the future? Gee, the public needs to know about this. Anyway, so sometimes this was me. You know, other times this was me. But you know, so you know, a lot of protests, a lot of activism. Celebrities got involved too, and you know, sure, we actually did get a ban on fracking. Okay, so then some kind of hubris kicks in, and they're saying, "Oh well, this is just the beginning. If we banned it here, we can ban it everywhere." Well, that didn't happen. Why didn't it happen? It didn't happen because we actually need energy. And when you get right down to it, you know, the places that banned fracking are places that didn't have a whole lot of gas reserves in the area, and that actually includes New York. So, you know, the bottom line is there's a reality factor here. They're probably going to continue fracking in Pennsylvania until the gas is gone. You know, this is the situation we're in. We have to figure out solutions to our energy needs. It's not just stopping the drilling. So that led to an effort by a lot of environmental groups to push for changes in how we look at energy, and the passage of the Climate Leadership and Community Protection Act with some powerful, ambitious goals associated with it. And this is also, I have to say, where I diverged from some of my colleagues, or many of my colleagues in the environmental community, because as an engineer, I could see that we were going down a path that's going to, you know, make some difference. More and more renewables can help, but it's not going to go the distance. And I could also see that we're potentially going to, so we're not going to meet our goals, but we're also going to potentially do a lot of ecological harm in the process. So, because after all, if that is sprawl, then, you know, isn't that sprawl too? So anyway, so you know, Climate March happened this week. A lot of people marching in the street, and they were saying things like this: we need to get 100% renewables. We need to do it by yesterday or almost yesterday. And you know, it gets mixed in with these other kind of off-topic subjects. Upstate, it's a very different picture. You have folks who don't want this to happen. Upstate New York, like Eric said, is already largely decarbonized. Its grid is largely decarbonized because of nuclear and hydro. Yet upstate New York is being asked to shoulder the burden with lots of solar, lots of wind projects, and there's pushback on this. There's lawsuits being filed and things like that. And frankly, I got to say, there's also a sentiment that the big green groups have kind of abandoned the public on this issue. So what do people want? You know, people want to preserve their way of life. They want to preserve the rural areas. They want to preserve the environment. And, you know, there is evidence to show that there is potential significant harm if we go, if depending on how far we go with all of this. So let's talk about that. You know, I'm not going to talk about shadow flicker and things like that with wind. I'm going to talk about something I understand. I'm going to talk about land, okay? Let's talk about land. So I think many of you know this already. Just a very, very small land footprint for a nuclear power plant compared to the alternatives in terms of wind or with solar. Now, there's an asterisk here that says it depends on the actual capacity factor, and that's true. So let's look at a real world example. It's not a pleasant example. It's an example that I think is unfortunate. New York lost its largest source of carbon-free electricity, single most largest source of carbon-free electricity when it shut down Indian Point. We're burning more fossil fuels because of it. What if we try to replace that with solar? How much solar would it take? Well, Indian Point occupied 240 acres of land. It would take 60,000 acres of solar panels to come up with the same amount of annual energy that Indian Point made, the 2100 megawatt reactor. So, and you wouldn't be getting electricity that's useful. You would be getting electricity peaks in the summertime, peaks when the sun's out, but not baseload electricity that we need. So that's something to be aware of. And the other aspect of this is the material contributions toward building different forms of energy. This is a graph that shows you where things stand. And, you know, I could show you another graph similar to this about rare earth type of elements, things like that. But this is just the nuts and bolts, the steel, the cement, the aluminum, copper, glass. by far, nuclear has the smallest material footprint, so that's less mining of materials. And so people might say, oh, well, Keith, you're forgetting something. Nuclear uses fuel. You know, the wind is free, the sunshine is free, there's no fuel there. So, okay, let's throw fuel into that picture. Okay, throw fuel in the picture. Yeah, it swamps things out. Gas, coal, huge red bar. How about nuclear? There's actually a red bar in there too, but you can't see it because it's so small. Very small footprint as it relates to the fuel. And that also translates to less nuclear waste as well, as we heard from the last speaker. So, and you know, this is why, you've heard it before, I think, 1 uranium pellet is 1 ton of coal in terms of energy. It's just massive difference there. And so average life cycle land occupancy, when you do the math and put those things together, material and actual direct land impacts, it's just phenomenal, the amount of land that's saved by going with nuclear power. Here's on a logarithmic scale, you have something similar. Those of you mathematics folks understand that, you know, logarithmically, you know, this is a way of compressing information. Nuclear is very small. There's biomass way up there. That's about the most intensive land occupation type of land intensity of renewable sources. So anyway, if we can find a source of energy that has a very small physical footprint and uses very little material, then what are we doing? We can protect this. We can protect farmland and we can protect nature. And here's another UN graph, okay, that did that analysis, and it shows where nuclear is in terms of ecological protections. So maybe that's why this guy was a big proponent of nuclear power. Nuclear power is one of the chief long-term hopes for conservation. Well, who is this guy? Oh, gee whiz, it's the Sierra Club board. He was on the Sierra Club board of directors, the president of the Sierra Club, in favor of nuclear power. So this is when they were in favor of it before they were against it. But believe it or not, Sierra Club was a proponent of Diablo Canyon when it first came on board. Same thing, Ansel Adams, the fellow who's taken these beautiful, iconic images of around the country, on the board of directors of Sierra Club, big supporter of nuclear power. And of course, this guy, the person who taught us about climate change, the grandfather of climate change, here's James Hansen testifying before Congress in the 1980s about the reality of climate change. He's a big proponent of nuclear power. This is him in 2022 at the New York State Climate Action Council hearings, and he didn't hold back. He basically said, you know, folks, you're pursuing a plan that is going to make New York the Germany of the United States in terms of a failed energy policy. So what was he talking about? He was talking about this. This is the New York State plan by NYSERDA that's been proposed for how do we get from where we are today to where we want to be in the future. It's predominantly based on renewables, wind and solar. And well, why is it escalate so much? Well, part of it is we need more energy if we're going to electrify everything, but most of it is actually we're picking underutilized resources, underperforming resources. The capacity factor of solar is so much less than nuclear, and so this is what you're seeing here. Plus, you need storage. Plus, you need some backup generation. This firm dispatchable emission-free resources, and how much of that do you need? Well, you need almost as much fossil fuel, as much capacity as for backup generation as the fossil fuels you got today. So, you know, when you look at it, you spread this out. Let's just, you know, I'll go through this very quickly. How much solar? NYSERDA was suggesting upwards of 55,000 megawatts of large-scale solar. That translates to about 400 to 600 square miles of land. Okay, that's about 22 square miles of land every single year that has to be converted from whatever it is today, farmland or forest, into glass, copper, and steel. That's what we're talking about. That's an area about the size of Albany. So same thing with offshore wind. A lot of wind turbines that would have to be built. About one would have to be built every 4 or 5 days. Onshore wind, we would have to do that too, according to NYSERDA's plan, a tremendous amount. Plus, we'd have to be bringing in electricity from onshore wind from other places. Transmission, we would need, you know, they say roughly you need double the transmission to if you're using intermittent sources, and then you maybe have to quadruple it if you're also electrifying everything. So we're talking about additional transmission, a lot of storage also. So the largest battery plant in the whole world is the Moss Landing plant out in California. We need about 100 of these according to NYSERDA's projections. And then I said, like I said before, we need something to back it all up. Firm, dispatchable emission-free resources, what they call DFRs. Basically, when you don't have the sun and you don't have the wind and your batteries are depleted, what are you going to do? So the state has proposed hydrogen as the solution for that, which I kind of think is really not accurate because hydrogen is more of a storage feature rather than firm generation when you really think about it. But you would need a whole lot of this. And for those who think, well, at least we're not going to be building those darn pipelines anymore, think again, because we would need 400 miles of hydrogen grade pipeline. This is extra thick steel pipelines that would have to be built to support this. So again, how much of this backup generation you need? About the equivalent of our total capacity of fossil fuel generation in the state today. It's kind of shocking. So if this kind of sounds like this, you've seen these Rube Goldberg cartoons, you know, where you basically take a straightforward thing and make it as inefficient and complicated as you possibly can. Does it seem like that's kind of what we're doing here? Well, it kind of does. Is there a better way? Yeah, there's a better way. We know what the better way is. A lot of our electricity is baseload electricity. It's something we need all the time. So if you have a source of energy that that runs 100% or almost 100%, then let's use that. If you have a source of energy that doesn't need batteries because it's already giving you electricity when you need it, so let's use that. Or if you have a source of energy that's already reliable, then you don't need the backup generation either. So nuclear can be a big part of the solution in our view. It needs to be part of not just the backup of an intermittent energy system, but part of the backbone of an efficient energy system. And so we're with this lady right here, the Secretary of Energy, Jennifer Granholm. She said, we're bullish on advanced nuclear. Nuclear is dispatchable, clean baseload power. We want to bring more of it on. If we were to do that, and this is just kind of a back of the envelope type of calculation, but you know, I support renewables. I think we need renewables. And I think we're going to need more renewables in the near term as well. So let's say we do that. We build out renewables, but then like in the 2030s, 2035, when the new advanced reactors are going to be readily available, let's start building those. Then we have a picture that moderates the matter and is much more realistic, I would say. And I would say much more respectful of the communities that would be hosting the solar and wind projects upstate, because it's part of a system that can actually meet our energy needs. So, you know, New York is a tough nut to crack. You know, it's going to be tough here, politics and everything that goes with that. But I will say that most recently, we've had some positive progress. New York State ended up coming up with a scoping plan for implementation of the CLCPA. And they made some modifications to it. They received input from Nuclear New York, from New York Energy Climate Advocates, from other groups, from labor unions, because the labor unions understood. They understand that the good jobs are not going to be in unpacking solar panels from China. The good jobs are in nuclear power. They were weighing in on this too. And as it turns out, the state gave a presentation to the Climate Action Council showing that if we were to build 4 gigawatts of additional nuclear, we could save 12 gigawatts of intermittent generation and save on avoiding 5 gigawatts of firm backup generation. So that's some progress. Some people are starting to listen. So this is where I want to conclude here. What's the solution? The solution is a credible climate plan that doesn't discriminate against viable carbon-free resources. And you know, I know that word discrimination is something that is a loaded word, but you know, when you get right down to it, what is discrimination? What is prejudice? That is when you're passing critical, unfair, biased judgments against people or things that you don't understand, that you don't try to understand, that you don't want to understand. There's no place for that in society, and there's no place for that in when we're looking at our energy technologies that are going to be needed to meet the needs of society. So that's basically my conclusion. If we come together, get through these impasses, and make nuclear part of the future, we can give our kids a future. Thank you.
Thank you, Keith. If you stay on stage for a minute, I think we'd have time for 1 or 2 questions. If anybody has one? Yeah.
And also, I'd like to invite some of my colleagues from Nuclear New York to the stage too. Maybe if Siri wants to come up here. Go ahead. Thank you.
Yeah, Jim Meggs from Manhattan Institute. I've written about this before, but I'm just wondering if you might agree with this idea that the term renewable is one of the most misleading things that we could say. It came up in Christina's presentation too. We're using this term based on a 1970s concern about running out of energy, and the idea that renewable means it endlessly renews itself, as opposed to pragmatic, hard-headed decisions about its cost and its carbon emissions. What do you think about changing the dialogue a little bit to help people understand that the word renewable in and of itself doesn't really mean that it's environmentally preferable?
I think you make a very good point, and I think the graphs I was showing here about the material lining up all the different comparables makes the point you're making. I think you're right. It's something we need to figure out how to talk about that. Renewables, unfortunately, I mean, well, if you really think about it, renewables are what is renewable? When I think of renewable, I think of an inexhaustible resource, okay? Something that you're not going to run out of, right? Nuclear power is that. Especially if we're starting to refine, get uranium out of seawater, we have enough uranium to probably last the rest of human existence on Earth. So, and I'm not saying that's the only way to do it. I mean, just right now, we also have, I think within our existing stockpiles of nuclear material, using advanced reactor technology, we could, I think somewhere like 100 to 300 years worth of energy that's right there without having to mine anything else. So, I mean, I think you make a valid point.
Yeah, I mean, I think you address a really important point. What you measure impacts how you make your decisions, right? So if you look at NISO, our electricity grid operators website, they show percentage renewables. They don't show percentage carbon-free or clean or sustainable. So this is a kind of a paradigm shift that we think is essential, especially with regards to these biofuels and stuff like that, where you're destroying lots of land. So we just need to get better educated and think about other dimensions of materiality, sustainability, affordability, reliability, other than this one kind of narrow-minded definition of renewables.
Yeah, I understand that New York City has a requirement that we, large developments or housing buildings need to go 100% electric and get away from, I guess, oil and natural gas. I guess without nuclear, aren't we facing like a terrific increase in cost?
I think you are facing an increase in cost, that's for sure. And there's also, I think, a feasibility question as it relates to that. I'm in favor of electrification of things. I think that is part of the solution. I think we need to do that. And I have geothermal in my house myself that we put in. So I walk the talk on that. But if we don't look at where that electricity is coming from, then we're not solving the problem. So do you have anything else to add to that, maybe? Okay.
Is this thing on? I'll save the last question for myself. Keith, you are, I think, an old school conservationist, if that's a fair characterization. Not that you were a contemporary of John Muir in the
John
1800s, but yeah. And I think that you deal a lot with the technicalities of how grids actually work, but a lot of the environmentalist movement is kind of cultural in a way, and there seems to be a cultural divide between old school conservationists and the new school climate marchers. So how do you think we can bridge that gap?
I think we haven't done enough to actually talk about how nuclear power itself is part of the answer to some of the social problems we're talking that people like to talk about. People should talk about. There's a great piece that Chris Kiefer, I think, has put together on environmental justice and how that relates to nuclear power. If we understand that developing nations, they need energy, they're going to go for energy however they can get it, it'll be fossil fuels, they'll make the same mistake we did if they don't have access to some alternative. People in developing worlds have a right to have a quality of life. Who are we in our comfortable couches at home to say that they don't deserve that? If you really think about the needs of people, we're going to need electricity. We're going to need a lot of energy in the future. It's something that if we're going to meet the needs of society, we've got to figure out how to provide for that. I am a proponent of wind and solar. I think that's part of the equation. But like somebody else has said already, especially developing nations, India and so forth, there is tremendous need for energy, and nuclear is the only way that's going to actually satisfy the bulk of that.
Well, let's hear it for Keith Schue, everybody.